Okay, so today we're going to learn about flow rates and dosage rates for intravenous medicines and IV administration of meds. Be aware of calculation errors. IV administration of medication provides rapid access to the patient's circulatory system. If you look at this pie chart here, it says all the different potential hazards. So there are hazards in calculation, preparation, and administration of IV meds are very important. So find the percent of medication errors due to administration errors. So if we look at administration errors, if we wanted to find the percent of the people that had administration errors, we can say it was 927 people. 927 people out of a total of 1,563. And then if we times that by 100, we're going to get the percentage. So we do 927 divided by 1563. And then we times it by 100 and you'll get 59.3%. What? So be careful when you're administering meds. So there other cases of other causes of medication errors are human factors, systems, abbreviation. That's why you have to know that page 38 abbreviation chart. Oral orders, always take orders that are written down. Look-alike and sound-alike drugs. So look-alike drugs, they look the same, but they're different. And sound-alike drugs means you're looking for the tall man letters within the order, because if there's large letters in the order, it means that there's a sound-alike drug also that might have a letter off or something, and it will be a different drug and that does different things. So your dosage calculations and your at-risk drugs. IV piggyback infusions. So here there's little medication in here and there's usually diluent in here and they come together. So the flow rate we're going to use is volume over time, and the dosage rate, because the drug rate that it comes down is going to be drug over time. So your example is cimetidine, 300 milligrams IVPB every 6 hours in 50 milliliters of normal saline, and then to infuse over 20 minutes. So the drug itself is called the cimetidine. The amount of drug is 300 milligrams. It's diluted in 50 milliliters of normal saline. The duration is 20 minutes and it's repeated every 6 hours. So remember back in the day when you got prescriptions, it looked much like this guy in this picture here. He's like, hey guys, look at this email from my doctor. I mean, where do they even get that font? It's funny. So find the IV flow rate measured in milliliters per minute. So you're going to look, they need milliliters on top and minutes on bottom. So the milliliters you have are 50 and minutes you have are 20 minutes. So you're going to do 50 milliliters over 20 minutes. And if you do 50 divided by 20 in your calculator, you're going to get 2.5 milliliters per minute. Okay, find the dosage rate in milligrams per minute. So now we don't care about the milliliters, we're defining milligrams per minute. So we're going to go back up here and we have 300 milligrams still in that 20 minutes. 300 milligrams still in that 20 minutes. So if we do 300 divided by 20, you get 15, and then it'll be in milligrams per minute. And that's the dosage rate. So here the order is cefoxitin, 1 gram, IVPB bag every 6 hours over 30 minutes. You're going to find the dosage rate in grams per hour. So go ahead and stop the video at any point and try and figure out how to do these and then come back, because I'm just going to go through them. So the dosage rate in grams per hour, I need the grams, 1 gram over 30 minutes. And then I need minutes to be an hour. So I'm going to say 60 minutes is an hour. 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 60 minutes is an And I can do that because my minutes will cancel, and then my labels are left with grams per hour. So I'm going to go 1 times 60 divided by 30 and get 0. 60 divided by 30. Use a calculator because you don't get 0. You get 2 grams per hour. Find the dosage rate in milligrams per minute. So I'm going to do this gram in milligram will be 1,000 because 1,000 milligrams is a gram per minute. It's over 30 minutes. I'm going to go back to the original equation for that. I'm not going to use the one that I just did because I'd have to do a lot more conversions. So I'm going to go 1,000 divided by 30 minutes, and I get 33.3. So I'm going to say 33 milligrams per minute. The medication order reads heparin, 1250 units per hour through an IV. See the label and calculate the infusion rate in milliliters per hour. So I need milliliters per hour, and all I have are units per hour. So since hours in the bottom, I can start with that with hours in the bottom. So I can say 1250 units per 1 hour. But so I need milliliters per hour. So I have my hour, but I need to change my units. So I'm going to say times whatever units. And it says see the label. So I'm going to look at the label, and the units are right here. I could either use the top one or the bottom one. I want to use the smaller one. I want to say 50 units is in 1 milliliter. Because when I do that, I can cancel out my units, and I'm left with milliliters, which is what I need, hours, which is what I need, and then I can do my calculations. And I can say 1250 divided by 50 and get 25 milliliters per hour. The prescriber writes an order for 1,000 milliliters of 5% dextrose in water. This should say / with 10 units of pitocin or oxytocin. Your patient must receive 3 milliunits of this drug per minute. Calculate the flow rate in microdrops per minute. Remember when you see the word microdrops from chapter 10, you know that there are 60 microdrops per milliliter. So this says I need the rate in microdrops per minute. So I'm going to start with the tubing, which is 60 microdrops per milliliter. But I need milliliters to change to minutes, so I want to put milliliters here. And when I look at the problem, I have this with 10 units. So there's my milliliters, 1,000 milliliters with 10 units. Milliliters cancel, and I'm left with microdrops per unit, but I need it per minute, so I'm going to keep going. And then the only other thing that I see up here is this 3 milliunits per minute. So I got to get 3 milliunits is how many units? The way that I can do that is you can think about milligrams to grams. In order to do that, you have to divide by 1,000. So it's the same thing. This M is the same. So there are 1,000 milligrams for every 1 gram. So there are 1,000 milliunits for every unit. So I can say 1 unit has 1,000 milliunits, and then I can use 3 milliunits for 1 minute. So I can also say that 1 milligram is 0.001 gram. So I can use the fact that 3 milliunits would be 0.003 units. Either way you get it, when I cancel my units, so I'm going to cancel units with units and milliunits with milliunits, and I'm left with microdrops per minute. So I do the calculation. I'm actually just going to take out this and take out this because it's the same thing. So I'm going to cancel because I think it'll be easier. And when I do all my math, I'll get 18 microdrops per minute. So I'll do 60 times 3 divided by 10. Calculate the numbers of Humulin R a patient is receiving per hour if the order is 500 milliliters in normal saline with 300 units of Humulin R and refusing at the rate of 12.5 milliliters per hour via the pump. So what is this question asking me? It says that what I want to do is calculate the numbers of units per hour. So I need units per hour. And here it says 500 milliliters with 300 units. So I'm going to put the 300 on top so that the units match the units here. So 300 units for 500 milliliters. And I have to get rid of milliliters because I need it to go for hours. And here it is, 12.5 milliliters per hour. And then my units match my units, and my hours match my hours. So I'll say 300 times 12.5, and that's 3750, and I would divide that by 500 and get 7.5 units per hour. An IV bag contains 1,000 milliliters of normal saline with 500 milligrams of a drug. It is infusing at 12 drops per minute, and the drop factor is 10 drops per milliliter. If the recommended dose is 0.5 to 2.5 milligrams per minute, is the infusion in the safe dose range? So with safe dose range with IVs, this right here, I have to get this to match. So I'm going to get this up here in milligrams per minute and see if that fits in there. So milligrams per minute is my goal. And I'm going to start with milliliters with milligrams. So I'm going to start with 500 milligrams on top so that it's on top for my answer over 1,000 milliliters. And then I have to get milliliters to be minutes. So I'll times it by some certain milliliters. And I'll look up here and it'll say it's the drop factor is 10 drops per milliliter. Now if I end though, I'm going to end in minutes, but I don't want that. So I'm going to keep going to get rid of drops and try to get it to minutes. So then when I look back up here, it says 12 drops per minute. When I cancel it out, I'm left with minutes, which is great because I want to be left with minutes. And then I'll do my calculation. I'll say 500 times 12, and then I'll divide it by 1,000, and then I'll divide it again by 10, and I'll get 0.6 milligrams per minute. And does that fit in here? Yes, it does fit between, so it's safe. It does fit between 0.5 and 2.5. So the order is heparin, 40,000 units continuous IV in 1,000 milliliters of 5% dextrose in water, and to infuse at 30 milliliters per hour. Is the order the safe dose range? If a normal heparinizing range is between 20 and 40,000 units per day. With IVs, I'm going to look for units per day, and I'm going to get this whole thing into units per day. And just looking at it, I know that it's going to be a big amount because it's 20,000 and 40,000. So it has to be between there. So the units, I have 40,000 units in 1,000 milliliters. But I need to get milliliters into days. So I need to find something with milliliters up here, and it says 30 milliliters an hour. So 30 milliliters an hour. And then I got to get hours to days. And I know that there are 24 hours in one day, which is awesome because it cancels my hours. And I'll have 40,000 times 30 times 24. And then I'm going to divide it by 1,000. And I have 28,880. So I have 28,800, my bad, units per day is safe because it fits in between 20 and 40. So if it was less than 20, there wouldn't be enough to get the patient better. And if there were more than 40,000, then it would be too much. It would be an overdose. So here we have a patient is receiving an infusion of 0.5 milligrams per minute. The concentration on the IVPB bag is 100 milligrams in 200 milliliters. How long will it take the patient to receive 40 milligrams? So the question here is how long, so I need a time. Remember, if the time is over 60 minutes, you need to put it into minutes and hours. So the only thing in time that I see is 0.5 milligrams per minute, but minute has to go on top because time has to be your answer with no denominator. So I have to times it by a milligram to get rid of it. And here it asks you to receive in 40 milligrams. So you're going to say times 40. And 40 divided by 0.5 will be 80. And you're left with minutes. So you're going to say 1 hour, 20 minutes. You wouldn't say in 80 minutes, go blah, 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 blah. You would say in an hour and 20 minutes, blah, 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 blah. Okay, the next question says, how many milliliters will the patient receive in 30 minutes? Well, they're asking how many milliliters, so you need milliliters now with no denominator. The only thing with milliliters that I see in this whole thing is 100 milligrams per milliliter. But remember, for 200 milliliters, but remember milliliters has to go on top because you end with milliliters. So 200 milliliters for every 100 milligrams. But now you got to get rid of milligrams, so times milligrams. And then up here, I see 0.5 milligrams per minute. So 0.5 milligrams per minute. Those cancel, and I'm left with minutes, but I need it in milliliters, so I need to get rid of the minutes. And here I have 30 minutes. So times 30 minutes over 1. I'm going to do my math. And my math would be 200 times 0.5 times 30. And you get 3,000. And you're going to divide that by 100. And you'll get 30 milliliters in 30 minutes. That is awesome. So I'm going to do a second video for this.